Sorry, but yeah, when you watch the class recording, I just go to those. So it only takes the 10, 15 minutes we looked at it together in class. Uh-oh, you a Thunder fan? Thunder?
Oh, yeah.
You like them?
Mm-hmm.
They're not my team, but they do a really good job of drafting new picks.
Mm-hmm.
They get lots of good new players. Do you follow that stuff pretty closely?
Not right now. I'm mostly focusing on like the NFL right now. Not doing fantasy.
I was gonna say one of your guys is in a lot of trouble.
I know about Josh Giddey. Yeah, that's a bit embarrassing.
Yeah.
Interesting.
There's gotta be, since they're letting them play and stuff, I'm hoping they know more about it and know that it's okay or like something didn't happen.
Yeah.
I'm hoping. He's a pretty good player too.
Let's do today, right?
Yes.
There's water.
That's Crystal. I know we're working hard.
Good morning, FHS. Happy Friday. It's December the 1st, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and have a happy Friday and a great weekend.
All right, before we start off today, I had asked you yesterday to turn in number 64 in the Google Classroom. So if you didn't do that in class yesterday, or if you didn't do it for homework, this is your last chance to still get full points on it. So I've already got a couple in here, but if you did not put that in Google Classroom, I need that now if you want full credit. Later will be half credit. I will accept more half credit or anything since we've taken the curve sketching test assessment, which is what we did right before break, up till the final exam. So if for some reason you don't have yours today, you can still get half credit, late credit, but it has to be fully complete as always, and in this case I need it before the final exam. Okay, so most of class today I will be able to give you some time to start working a bit deeper on that semester exam review. I'd asked you to do 10 of those yesterday, or probably for homework. Because the more times you work on it, the less questions you'll need to have to worry about getting done each time. But there is the handout from this morning, 67. I'd like to talk about that briefly with you. just kind of goes over one more thing that you need to know about Riemann sums and trapezoidal sums. So let's talk about that. And then I'll discuss the exam review and give you some time to hopefully get a good chunk of that underneath you. Okay, so a common, not a super common, but it does usually get asked at least once a year about Riemann sums or trapezoidal sums is if they are overestimates or underestimates, meaning is your estimation a little bit bigger than the actual area, or is your estimation a little bit smaller than the actual area? So there's a couple things that we need to consider, and then I have an example piece of the FRQ so that you can see how that has been asked in the past and see if you can answer that after we do this little table here. Okay, so we need to sketch a little function that has a positive first derivative. So what does that mean when I sketch the function?
It has positive slope.
Okay, positive slope and positive second derivative. What does that tell us? Okay, so we want it to be increasing, but we want it to be concave up. So imagine this was the curve, this is the function, and perhaps, now of course on multiple choice, usually the question is just, hey, do this left sum, or do this right Riemann sum, or do this midpoint sum, or do this trapezoidal sum. It tells you which one to do. Same with FRQs. I know we did that one practice FRQ where like part 1 was left, part 2 was right, part 3 was midpoint. It doesn't usually work that way. Usually it's just one of them at a time. But if you were to do a left Riemann sum, imagine if you took, I don't know, it doesn't matter what values we look between. Let's just say A and B here. If I did a left Riemann sum, and I'm going to just try to sketch in a couple of these to visualize. From the left point, move to the right. From the left point, move to the right. Left point, move to the right. So I'm just pretending like I'm doing a left Riemann sum with 3 intervals like this, so that I have a visual. So if I added up the area of each of these rectangles, do you see why that has to be an underestimate? Do you see why it's less than the actual area? Because it's missing some here, missing some here, and missing some here. And it didn't overestimate anywhere else. So from this, we can see if it's increasing and concave up, a left Riemann sum would be an underestimate. That your estimation is less than the actual area. Okay, but it could be different for right Riemann sum. And basically what I'm doing here is what I would suggest you do when you see this on the test. Give yourself a small little example to look at. It makes it a lot easier. I'm not suggesting you memorize these rules by any means. But if I did right Riemann sum, I would need to take the right point, draw to the left. Bless you. Take a right point, draw to the left. Take a right point, draw to the left. So right Riemann sum, is that an underestimate or overestimate? Overestimate. A little too much, a little more too much, a little more too much. And nowhere did we miss anything. So we are sure that the right Riemann sum would be a overestimate. Okay, this one's definitely harder to see and helps if you make your picture as big as possible. But if we did trapezoidal, we could do like this. So try to sketch in a couple. Do you think a trapezoidal would be, and again it's really close, so it's a little harder to tell, but do you think it would be under or overestimate? I agree. It is an overestimate. Okay, let me show you the next little table piece, and then I'll have you try the next one. So that is if your function is increasing and concave up. But what if your function was decreasing and concave up? Decreasing and concave up. So draw a little picture there. I mean, you can pretend, that there's like a X and Y axis if that helps you. But let's think about left Riemann sum. So left Riemann sum, I would go to the far left, draw it to the right, far left, draw it to the right, far left, draw it to the right. Looks like if it's decreasing and concave up, a left Riemann sum would be an overestimate. A little too much area 3 different times. Okay, whereas a right Riemann sum, we would take a point from the right and move to the left, a point from the right side, move to the left, a point from the right side, move to the left. So if you just make up, you can see there's not a real function here. All I did was show that it was decreasing and concave up. There's not real values between A and B. I'm just drawing something to give myself a visual. And with my visual, I can see this is definitely under. The right Riemann sum in that scenario would be an underestimate.
Wait, shouldn't it be overestimate for left?
Yeah, did I just write it down wrong, or did I say it wrong too?
I think you just wrote it down.
Okay, then I won't go back to it. Okay, and then one more, and then I'll have you try the next one before we talk about it. If it was trapezoidal, again, a much smaller difference. So you could try to sketch in a couple trapezoids to help you. And it's pretty tough to see. But one thing that would maybe make this a little bit easier is I could try to emphasize the decreasing part a little bit more. That probably would make it stand out a little bit better. Well, this would actually go here. Okay, so do you think that's going to be overestimate or underestimate? Okay, just barely, but it is over. Because, and I'm going to kind of summarize what's making these one way or another, but I'm just wanting you to see that without memorizing, this is over, without memorizing them, just doing a quick little sketch, you should be able to push yourself in the right direction to say whether it's over or under. Okay, but I'd like you to try the third box before I just tell you. This one is when your function is increasing and concave down. So make an increasing line and then try to make it concave down. And try drawing in a couple rectangles and a couple trapezoids until you feel confident whether it be a left or an under or overestimate. And go ahead and try all three. Okay, so left would be from the left drawn to the right, from the left drawn to the right, from the left drawn to the right. So just a couple quick examples, and I can reasonably say that's an underestimate. It's always going to miss some area that direction. Okay, from a right sum, so if I go take a point and go from the right to the left, start at the right side and go to the left side, go from the right side, go to the left side, a right Riemann sum is going to overestimate how much area there would be. And hopefully I did this picture a little bit better, but trapezoidal sum, I guess if I try to make the height of these trapezoids a little bit better. Trapezoidal is almost perfect, but this one would be just barely an underestimate. There's just a tiny bit of area that it's going to miss each time. It's stuck underneath it. Okay, so make corrections if you need to there, and then go ahead and try the last little part of the table before we go over it. Okay, what did y'all think for left Riemann sum? Okay, I agree with that. Left to right, a little too much. Left to right, a little too much. Left to right, a little too much. It's going to be an overestimate. Okay, somebody else, what did you get for right Riemann sum? Okay, I think under should be fine. Starting from the right and going to the left. Right, go to left. Right, go to left. That's definitely a little bit under. So that would be an underestimate. And then trapezoidal.
Underestimate?
I believe that is correct. Again, I don't memorize any of these. Let me space this out a little further. I just always make a quick little sketch when I need to know. Okay. Again, it's almost perfect, but it's under just by a little bit. Okay, you guys okay with those? Okay, so we need to kind of summarize what makes you have an under or over estimate. So notice these, if we compare these two, both of these two were increasing. If your function's increasing, your left Riemann sum is going to be an underestimate, and your left Riemann sum is going to be an underestimate. Your left Riemann sum is always an underestimate if the function's increasing. Whereas the left Riemann sum is going to be an overestimate. Left Riemann sum is an overestimate when your function is decreasing. Didn't matter about the concavity. The concavity only mattered for the trapezoidal stuff. So if it is concave up, like these two, your trapezoidal sum was an overestimate. And if it is concave down, your trapezoidal sum is an underestimate, just like both of these. So increasing, decreasing determines whether it's the left Riemann sum or right Riemann sum's over and underestimate. And then trapezoidal is determined on the concavity. So again, you can always just make a quick little example of what you need, but to prove to you, they do ask you this, and just kind of a random opportunity to give you a good challenge question. This was just a couple years ago, 2001, very first FRQ on the exam. FRQ1 is a calculator FRQ. But if you really want to try Part B, I don't care if you try it or not, but I wanted to at least tell you what it is and ask you to write it on your page. This year, on Part B of that FRQ, they asked people to do a right Riemann sum estimation for that. I don't know how I didn't get that copy down. But the reason why I'm pointing this out to you, and I'll jot the answer down if you want to give it a shot, it should end up being 269 pi. But the same reason that we have to try to look at a variety of questions and give you questions that take a lot of thought, this year was the first year that they ever did this, where the 2 pi just means you're going to multiply the area by 2 pi. The 0 to 4 means you're going from 0 to 4. F of r, you're integrating, so this is like area. You can do this Riemann sum just like you did the Khan Academies yesterday. But this was the first time ever, so nobody had time to prepare or plan or practice 50 of the questions, where they also threw in a little r right there. So as you compute the area, you have to also multiply some of your work by these numbers. So that's kind of hard to do on the spot, which is why we try to help prepare you by making you see as many different question types as possible. But again, if you want to give that a shot, if you want to try it, that's what the answer is supposed to be. So, but the part I want to talk about is Part C. Part C said, is the approximation found in Part B an over and underestimate? Explain your reasoning. So, based on what we talked about up here, it was a right Riemann sum. Right Riemann sum will be an overestimate if the function's increasing, and the right Riemann sum is an underestimate if it's decreasing. So you could plot these points and make a quick little graph to help you see that, I guess. But basically, as r gets bigger, these values get bigger. So the justification was because this is increasing, it would be a overestimate or underestimate. Right Riemann sums, if it's increasing, it is an overestimate. Again, you can actually plot those points if it helps you with the visual, but I just need you to know that if and when someday you see a question like that, you have some idea how to approach it. You need to either consider whether it's increasing or decreasing, and or whether it's concave up or concave down. Really, the concavity only matters for trapezoidal ones, and increasing, decreasing for left and right Riemann sums. But again, you don't ever have to memorize that. If you plot it, draw in a couple of them, you can figure out what you need in the moment. But this way, at least you have an idea of how to start it.
For the explanation of that, you have to reference just the function. You can't say the first derivative is positive.
The problem with saying that the first derivative is positive, that is true, but how do you know it's true?
Because the function is increasing.
So
You have to say that.
the problem with saying that the first derivative is positive is it creates a new question. How do you know the first derivative is positive?
Okay.
We didn't tell you anything about the first derivative up here. We told you something about the function. So your justification should really refer to the function. Like if you're, the fact that you're saying that means that you're like in the right ballpark. But again, just referring to the first derivative or the second derivative when we didn't tell you anything about the first or second derivative, you then would need to explain how do you know this is positive, which goes back to this. Why not just say that in the first place? So, okay. Again, this is just not a big topic, so we probably won't talk about this again, but you probably will see it on your AP exam. So, do you guys have anything you'd like to clarify on that before we move on? Okay. Then, I know you should have done at least 10 questions from the review to start moving forward, and I told you you'd have the bulk of class today. So I did not talk about the formatting of this, but this review is pretty lengthy. But part of it is, I know some people just like to work the questions in order. Question 1, question 2, question 3. They like the questions to be scrambled up. But sometimes people like to work them by topic. So a couple years ago, I went through and organized the questions by topic. So that's what the front page is telling you. If you prefer to work by topic, you can read some of the main things that we did this year. Like, I don't know, halfway down, there's one that says continuous versus discontinuous. That's an important calculus topic. There's a good chance that's on the final exam. There's no promise that is. We can't test everything. Even splitting it up over 2 days. Notice I did update the upcoming assessments part of our agenda there to match what I told you yesterday. And if you know you're great at that question type, I probably wouldn't prioritize that today. If you are really good with continuous versus discontinuous, save those for closer to the test. You still need to do them for practice. But if you're unsure, or if you know that's your weakness, it tells you that you should try questions 7 and 8. So especially when you've got people next to you that you can work with and talk to and compare answers to, and me to help out. If that's a weakness of yours, or it might be a weakness of yours, you might try question 7 and 8, check the answer, and then know if you're good with that or not. The back couple pages are the answers. So that's another reason why this handout is so long. Normally I wouldn't print out the answers for everybody because that's a lot of paper, but of course semester exam, trying to pull all this stuff together is where it really counts. So I think it's worth that, a little bit of extra paper. So that's up to you. If you want to pick a topic, try it out, make sure you're good with it. Pick a different topic, try it out, make sure you're good with it. I'm good with that. If you'd rather just start with question 1 and then question 2 and then question 3 and see where you get held up, then that's fine too. But if you do that route, there are a few questions on here you don't have to worry about, so you may notice those on the bottom of the front page. I don't take them off because they certainly don't hurt you. Good for you to try, but at the end of the day, if you don't know what to do with question 52, that's not a real priority right now. Your priority is making sure that you're good with the stuff that you might be seeing on the final. Okay, so I think that's it. So let me give you some time to work before I come around. There are also a couple typos on here, so feel free to ask if you think something's a typo.
How do you copy of the exam review?
It's going to be on the bottom of the bookshelf over there. And since I'm giving you guys so much class time here, and I'm considering asking you to do a little more for homework, you can see under the homework tab on our agenda, I'm asking you to have at least 30 questions done. Again, I'm just trying to give you a number to aim for, because after this week, I will only see you 2 more times. So you need to be making progress. It doesn't mean get to 30 and then stop, but if you don't feel like you have at least 30 questions done by the end of class, then you need to do some outside of class to get caught up. I don't want you to be overwhelmed the couple nights before your exam and feel like you have a ton of stuff to do. We need to break it up into small, manageable chunks, starting with yesterday and today. I know I've also mentioned this before, but a big part of your motivation at this point should be, in addition to just, wanting a good test grade, but this should go in as a 50-point test, so pretty similar size as your other big ones. If you remember, your limits quiz was only like 20 points, I think, but most of them have been about 40 points, so 40, 50 points. Actually, maybe you didn't have any 40-point ones. I don't know. Doesn't matter. But the final exam will be a 50-point, so it'll be comparable to that. But we also, if it helps, in addition to being a 50-point test, it can count as a test replacement. So if you had one test that was lower than the rest, if your final exam is higher than that, then I can put in your semester test as a grade, and I can go and replace that low test grade with your semester test grade. So that can bump your grade up quite a bit, but it also just depends on what your low test was, because some of them were worth 20 points, some were worth 50 points, how low your test grade was, how good your semester test grade is. There's a lot of variables, but your grade can jump quite a bit. So, only advice I'd give you there is just give it your best shot so that you don't feel like you missed out on that opportunity. Okay, now I'll actually be quiet for a few minutes.
any extra copies? I have no clue, but somehow I don't know where it
Of
is.
the final exam review?
Mm-hmm.
I do. They're on the bottom of the bookshelf.
Okay, thank you.
Is this supposed to be like approaching from both sides?
Yeah. That's supposed to be just as x approaches 0. No left or right.
Do you have answers in the FRQ posted?
I don't, but I will.
Okay.
So the answers on the back don't have answers for you to check the practice FRQs. So I'm going to take a few minutes and work those out so I can post those to the website and y'all can check your answers to those. But you're still welcome to interrupt me if you find a question, because I can finish this later.
on this page not like meant to be the limit and not the right limit?
It's supposed to just be the limit as x approaches 0,
Okay.
not from the right to the left.
Thank you guys for your time. What? It said the answer was infinity and I got -1/6, so. Oh, just-
Okay, in between working those, I want to give you guys a chance to speak up. I figured you might have some common questions, so it might be helpful to talk about some on the board. So, strictly just looking at the front page, as that's probably where most people have started looking. What from questions 1 through 20 have you tried and know that you need help with?
Number 5.
Number 5. Okay, so if you have not tried 5 yet, you might glance at it to see if it's one you want to pay attention to or not. Of course, you can always watch the video later, but okay, so with limit questions, they always start and end the same way. You're going to start by trying to do direct substitution. You're going to plug this in. You hope that you get a number, because if you get a number, you can assume that's your answer. But when you plug in 1 here, to the top, you would get 2 minus 1 would be 1. The square root of 1 is 1. 1 minus 1 would be 0. And the limit as x approaches 1 of the denominator also goes to 0. And 0 over 0 is considered indeterminate, which means it takes more work. And the answer could be anything. It might be 0, might be undefined, it might be 4, it might be -2/5. More work has to be done before you can figure out what it is. But because it's in indeterminate form, this is how I know I need to do more with this. Next semester, we will talk about L'Hopital's rule, and that will give you an option on how to do this one. But for now, you've got to algebraically make this look different. So the most common way to make that look different is factoring. I think that's what you should have done in question 2. But really, any algebra skill is fair game. And when I see this square root here, to me, this is probably one of the conjugate questions. So one of our algebra tricks that makes this look different without changing the size is to multiply the top and the bottom by the conjugate of the one that has the square root. So remember, conjugate means change the middle sign only. The reason this doesn't change the size is because anything divided by itself is 1, and multiplying by 1 doesn't change the size. So I believe that to be the approach I should take. So my denominator is going to be an x minus 1 times all of this stuff. My numerator is going to be these two things times these two things. So I'm going to go ahead and FOIL them out. That would be 1 times 1. 1 times the square root of 2x squared minus 1. Negative square root of 2x squared minus 1 times 1. And then finally, and this is the part you got to be the most careful on, a negative square root of 2x minus 1 times a positive square root of 2x minus 1, 2x squared minus 1 would be a negative 2x squared minus 1. But the whole thing's negative, not just a 2x squared minus 1. So you can either put parentheses or distribute. But square root of something times the square root itself is just a thing, but positive times negative makes the whole thing negative. So then 2x squared becomes negative, and the negative 1 becomes negative. Okay, I usually skip this step. Anytime you multiply something by its conjugate, the outer and inner part of FOIL cancel. You can also notice that some of this is going to combine. A plus 1 could be a plus 2. And with all of these indeterminate form questions, you need something to cancel before you finish with direct substitution. We started with direct substitution, we always will finish with direct substitution. So I would probably factor out a 2x GCF, or a negative 2, even better. And then now that I've factored out a GCF, I see that it factors more, because what was left behind was the difference of two squares. And then finally something can cancel, and finally direct substitution should finish and should no longer be in indeterminate form since something canceled here. So plug 1 into what's left over, we would get negative 2 times 2 on top. Plug 1 down here, we get 2 on bottom. So it looks like negative 2 would be your final answer. So of all the ways to deal with indeterminate form, multiplying by the conjugates is probably one of the messier ones, but it is also one of the more common ones. Not as common as just factoring like question 2, but it is one that I would be surprised if you did not see in your AP exam. So, okay, Anthony, is that enough? Okay, was anybody else going to ask about this number 5 and have something specific before I slide it away? Okay. Did you have one, Roya?
19.
19? Okay, 19 asks us to differentiate. So basically, find the derivative. And so this one looks like it's going to be kind of messy here. I don't remember all the steps to it. But since it's something divided by something, we would need to probably start off with the quotient rule. So, quotient rule, product rule, chain rule, power rule. All that stuff was really your second unit this semester. We've done like 4 or 5, depending on how you count them up. So you certainly need to know those rules. It says to take the derivative of the numerator times the denominator left alone minus the numerator left alone times the derivative of the denominator. And the derivative of the denominator, you would need to bring the power down, lower the power by 1, and remember chain rule. And if you don't remember, we don't don't usually do too much with the denominator. There's no sense in multiplying this out. So up here, I have 2 times a 1 minus 3x squared squared. Over here, 2 times negative 6 times a negative would be positive 24. X times x would be x squared. Okay, still okay?
Do you need to square the denominator a second time?
Second time?
Yeah.
Oh, I didn't do it, did I? I needed to square this. It was already squared, so when I square, it would come to the 4th. Yeah, good catch. Okay, the next one's a little bit harder to see, but we have seen this kind of algebra trick many times already now. So my numerator is 2 big terms. Here's a term, here's a term. Both of those terms have a 1 minus 3x squared. So I am going to factor it out like a GCF. And then you can say this 1 minus 3x squared cancels out one of these. Well, it was a 4. But one of these 1 minus 3x squareds and makes it 3 left over. And then honestly, I would be about done. There's not too much else I can do here. My denominator looks like this. And my numerator, I guess I can combine a couple like terms. This would give me a 2. And this would be minus 6x squared plus 24x squared, which should combine to be 18x squared. So personally, I would start to look for a landing place here. I'd start looking at your multiple choices, and I think this might be one with a typo. Let me double check. Did you end up with this answer? Yeah, okay. I'm pretty sure this is one with just the answer was wrong, but let me double check with the video on my website. Again, there are at least 2 or 3 typos on here. I apologize. Yeah, and this is one of them. So, if you did not think you needed to follow along with this one, you may want to at least make the correction on your answer sheet on the back. The answer on the back is not correct. So I'd hate for you to waste time thinking that you did something wrong when this one was just incorrect. But it is correct on the class video. So if you decide you need help with it later, getting it to that answer, I guess you can watch today's class recording or just the video set aside. Okay, let me let you do a few more so I can do this other FRQ and get these added to the website. But as soon as I'm done with that, I will let you ask a few more questions. Again, though, as you guys work through this, just keep in mind that this is trying to help you identify what things you learned and they really stuck and you don't need to study them anymore versus which things you're rusty on because you haven't used in a while. And of course, those are the things that you'll want to put your study and review time into.
I just finished it. Are you done with your stuff?
You're right.
Okay.
Yeah. Oh yeah. Yeah.
Okay, I think the FRQs, my work for the FRQs should be on the website now, so you're welcome to check those when it's convenient. You will have to refresh the webpage though for the new link to show up. Okay, but with that out of the way, again, try to sneak in a few more questions here since we have time. So, still focused on page 1. Have you guys tried anything else? Questions 1 through 20 that I can help with? Yeah.
On number 7, it says label the discontinuities as removable and non-removable, and I've already found like where the function is undefined, but I am not sure how to tell whether it's removable or.
Removable is like holes.
Right.
So if there was just a hole at like x equals 2, or a hole like this at x equals 5, both of these would be considered removable. Removable discontinuity is when you have a hole. All the other types are called non-removable. Anything else is non-removable. Is that your question or no?
I don't know how to figure it out.
Oh, okay. Well, so if we look at the function, we've got an x minus 2 over an x squared minus 4. But instead of thinking of it like that, let's think of it like this. Okay, so when you have a number that makes the top and the bottom equal to 0, like x equals 2 here, what does that do with the graph?
0?
Well, I mean, what does it look like on a graph? Okay, if there's a number that makes the numerator and denominator 0, that's when you get a hole.
Okay.
If you have a number that makes just the denominator 0, that's how you get a vertical asymptote. Vertical asymptote's going to create, I don't know exactly what this guy looks like, but vertical asymptote is going to create an infinite discontinuity, which would be non-removable, and x equals 2 makes a hole, which would be a removable discontinuity.
Okay, thank you.
Basically, it's, well, I mean, for this one, you do need to remember the difference between a hole and an asymptote. That part is important for this, but holes are removable. Everything else is non-removable.
Okay, thank you.
Okay, anything else 1 through 20?
On 14,
Mm-hmm.
I got 2x, but the answer key says negative 2x.
Yep, that's another typo. The answer should be 2x. The answer should be 2x. I've never, obviously I need to go through and fix these typos. I did not make this review, by the way, not that it matters to you, but that one you should know is a typo though, because if you did it with just the power rule, you should know it's 2x. So I have no idea how they got negative 2x. That's the easiest one to, actually doing it by the definition is harder, but you should still know the answer is 2x. Okay, then let me open it up a little bit to stuff from page 1 or page 2. Again, I realize that you aren't finished, nowhere near finished, but if you've tried some questions that you don't remember how to start, then let me help. And I'll keep the screen on and keep recording here a little bit longer, but you guys have about 15 minutes till you're free to go. But again, I think your benchmark should be, if you have less than 30 questions finished by the next time I see you on Tuesday, then you are probably kicking that can down the road a little too much and you're going to overwhelm yourself. I think 30 is a good minimum value. More is definitely good. I only see you 2 more times next week. And then the week after that, Tuesday, will be the calculator part of the final exam. I think that's 6 multiple choice, 1 FRQ. And then our scheduled Thursday time will be no calculator, which is your standard 9 multiple choice 1 FRQ. And also, I realize you guys have other classes and stuff, but if you know kind of what your study schedule needs to be, you might consider signing up for more primetime sessions next week. Even if you don't think you need a ton of help, if you know you're going to be spending some time studying, it makes sense to study in here so that if something shows up that you need help with, I'm nearby to help out. So. Okay, please speak up if y'all find something else while you're still here. Still got 13 minutes.
So the derivative of the numerator of y prime is 0? Or negative 2? Oh, yeah. It's 0.
Mr. Thompson, could I start my multiple choice?
You need to clear your desk. Clear your desk. You guys are down to about 5 minutes, so might finish the one you're on, find a stopping place, maybe ballpark about how many questions you feel confident with, and estimate from that how much, if any, you need to do from homework between now and next Tuesday.